with respect to the ability to produce H plus ions, solvents are classified into two types: protic solvents and aprotic solvents. Protic solvents contains OH or NH bond in their structure, and they can release H plus ions by self-ionization. Such solvents are called protic solvents. Water is an example. Water undergo dissociation to form H plus and OH minus ion. So solvents capable of releasing H plus ions by self-ionization are called protic solvents. They contain OH or NH bond in their structure. NH3, liquid ammonia, is another example. It dissociated to form H plus and NH2 minus. Similarly, alcohols, acetic acid, etc. are examples for protic solvents. Aprotic solvents do not produce H plus ions by ionization. So molecules do not having hydrogen atom like carbon tetrachloride, carbon disulfide, etc. are aprotic solvents. Molecules like benzene, chloroform, dichloromethane, etc. contains hydrogen atom, but they do not dissociate to form H plus ion. Therefore, they are also examples for aprotic solvents. So, solvents may be classified into polar and non-polar with respect to their dipole moment. With respect to their ability to release H plus ions, solvents may be classified into protic and aprotic solvent. For example, water is a polar protic solvent. Chloroform is a polar aprotic solvent. Carbon disulfide is a non-polar aprotic solvent, etc. For SN2 reaction, ideal solvents are polar aprotic solvents. Polar solvents assist ionization of a reagent to form nucleophile. As an example, dissociation of NaOH into Na plus and nucleophile hydroxide ion readily take place in polar solvents like water. In water, NaOH readily dissociated to form Na plus and OH minus ions. Each Na plus and OH minus ions are surrounded by a layer of water molecules. Aqua represent hydrated Na plus and hydrated OH minus ions. Due to this hydration, lot of energy is released. That energy is available for separating the ions. In other words, dissociation is favored in polar solvents. So concentration of nucleophile will be higher in polar solvents. In the case of protic solvents have OH or NH bond. So this nucleophile is surrounded by polar protic solvents. Say for example alcohol or something like there will be strong hydrogen bonds between nucleophile and solvent molecule. In other words, nucleophile is surrounded by a layer of solvent molecules. Protic solvents have OH or NH bond in their structure. So nucleophile will be surrounded by a layer of solvent molecules. Hence, this nucleophile cannot easily approach the carbon atom of a carbon halogen bond. during the course of a SN2 reaction. Since it is surrounded by a layer of solvent molecules, it cannot easily approach the carbon atom. In other words, nucleophile is surrounded by a layer of a solvent molecule, and as a result, the ability of a nucleophile to donate electron pair to carbon atom decreases. That is, protic solvents reduces nucleophilic ability of nucleophiles. That is, the tendency to donate electron pair is reduced by protic solvents. Therefore, aprotic solvents are ideal. Aprotic solvents do not have a OH or a NH bond. Hence, nucleophile is not strongly solvated. Here the solvation involves a hydrogen bonding type interaction. Its magnitude is very large. So in order to break this hydrogen bonding type interaction, lot of energy is required. Hence, SN2 reactions will be slower in protic solvents. It is absent in aprotic solvents. Aprotic solvents do not have OH or NH bond. Hence, polar aprotic solvents are ideal for SN2 reaction. Polar solvent assists the ionization of a reagent into nucleophile. Aprotic solvents do not strongly hydrate, or a general term solvate nucleophile. Aprotic solvents do not strongly solvate the nucleophile. Hence, polar and aprotic solvents are most suitable to carry out SN2 reactions. Two important organic solvents that are both polar and aprotic are dimethyl sulfoxide and dimethyl formamide. HCONH2 is called formamide. If these hydrogen atoms are replaced by methyl group, then the compound is called dimethyl formamide. It is commonly abbreviated as DMF. These two solvents are both polar and aprotic. They are ideal for carrying out SN2 reaction. Diethyl ether can also be used. Diethyl ether is ethoxyether. It can dissolve a large number of organic compounds. It is also a polar aprotic solvent. The hybridization of oxygen atom is sp3 and the molecule is not linear. It have an angular shape around the oxygen atom. Diethyl ether can dissolve a large number of organic compounds including alkyl halides. Hence it is called universal organic solvent. Universal solvent is water. Universal organic solvent is diethyl ether. It is commonly abbreviated as ether. It is represented like this, just like H2O, ET2O. ET represents ethyl group.